Hello friends, today we are going to see how to make use of the Excel sheet or the Excel software to obtain the numerical solution to a differentiation problem. So the problem has been stated over here. So we are supposed to find the value of dy by dx at x equals to 4.3 by forward and backward difference formula, that is the numerical method, by considering 5 data points with the difference of 0.1. We are supposed to compare the result with the exact solution, the solution obtained by analytical method. The relation between x and y has been shown over here. Y equals to f of x equals to 1 upon x. Now let us first start with solving this analytically. So we know that the equation has been given as f of x equals to 1 upon x or y equals to 1 upon x. So when we differentiate this, dy by dx of 1 upon x gives us minus 1 upon x square. So by substituting the value of 4.3 into the equation, we get the answer as minus 0.05408. So this is the analytical answer or the exact answer, we can say. Now to obtain the answer by Newton's forward difference table and Newton's backward difference table, how we are going to make use of Excel sheet, we will see now. So first of all, of course, we create the difference table for the Newton's forward difference formula. Here we consider 4.3 as the starting point and the column of x, and with a difference of 0.1 we have 5 data points over here: 4.3 starting with 4.3, 4.4, 4.5, 4.6 and 4.7. We know the relation between x and f of x. So here, as you can see, it is reciprocal of x, so 1 upon a11. This is a11. So we obtain the reciprocal of the same, which gives us the f of x column. The next thing is that we obtain the difference, as we can see over here. It is the difference between these two values have been noted over here or obtained over here by making use of the equal to and the formula as shown over here. And in this manner we obtain the first order difference, the second order difference and so on. So the difference table is obtained over here. Then making use of this formula of Newton's forward difference for dy by dx, we obtain the answer. So that has been obtained over here. So you can see in the formula column that we have taken it 1 upon 0.1 as per this formula, 1 upon h is 0.1. So 1 upon 0.1 into bracket the first difference C12, the second difference D13 into 0.5 minus 0.5, the third difference into 0.333, that is 1 upon 3, and the last value multiplied by minus 0.25. So when we obtain the answer of this, it is very much same to what we obtained by the analytical method over here. Similarly, we can obtain the same by Newton's backward difference table. Here what we are supposed to do is that we are supposed to create the difference table with the required data point at the end of the difference table. So we have to have 4.3 over here. So accordingly the data points, 5 data points have been taken with difference of 0.1, and then its reciprocal have been taken over here, and the subsequent differences have been shown over here. So we again make use of the formula specified over here and again shown over here in the formula bar, and 1 upon h, and then the terms of the first order difference, then the second order difference multiplied by 0.5, the third order difference multiplied by 1 by 3, and the last difference multiplied by 1 by 4. And again the answer what we are getting is very much similar to what we have obtained in the analytical method. So this way we can obtain the answers by numerical methods or specifically we can say Newton's forward difference method over here and Newton's backward difference table. The difference between the two tables is that where is the desired data point placed in the difference table. In the forward difference method we keep it or we place it at the start of the table, and in the Newton's backward difference method we place it at the bottom of the difference table. So this gives you the answer. This can be then saved and again can be used for another set of problem we can say. So I have copied this worksheet into a new one, as you can see over here, and even though the problem we are not changing, but we are getting the answer now for the same formula, but for a different data point, that is at x equals to 3.5. So at x equals to 3.5 we get the exact answer over here, and also we change the difference table, which is for Newton's forward difference, it is starting with 3.5 and the subsequent values we are getting over here. Similarly, in the Newton's backward difference formula we get 3.5 at the end of the difference table, and in both methods the answer what we are getting are similar to the analytical method. So in this way we can make use of the Excel software and obtain the solution for the numerical differentiation, provided we have been given the formula or the relation between x and f of x, and we know at which particular point we want to find out the value of dy by dx, and what is the difference that between the data points, that is the h value, and how many data points we are supposed to consider. So in this way we can make use of the Excel software to obtain the numerical differentiation. Thank you very much.